Looking for a roadmap but confused how to start and what to study? Well, this Edureka's video, we are going to talk about data scientist roadmap and how to become a data scientist. So keeping this in mind, our today's agenda, we will answer a very few crucial questions and cover the topics like understanding who's a data scientist, the role of a data scientist, what exactly does a data scientist do, the technologies to learn for a data scientist, what all to learn to become a data scientist, and how to structure the learning process. But before we get started, make sure you subscribe to Edureka's YouTube channel and hit the bell icon to never miss an update. Also, if you're interested in online training certification, do check out the link in the description. Now let's get started and understand who is a data scientist. Well, when the term scientist comes to our mind, the first thing is experiments. So scientists are related with experiments, and a data scientist is related with data and experimenting with that data. So a data scientist is someone who experiments with data and has certain tools and technologies at his disposal to draw insights and meaningful patterns from this data. So these tools and technologies are being listed here, and we will cover first machine learning. Now, this machine learning is a very important tool for a data scientist to build and test models. Also, another tool is programming language to extract, analyze, and manipulate the data. A data scientist also uses yet another important tool, and that is statistics. So now statistics is used to make predictive analysis, to understand and interpret the results from the data. So statistics is really important tool for a data scientist. So another tool is database. So database is yet another important tool, which means to access the data. Yet another tool is big data to work with complex data set. And big data technologies are really required now in a data scientist. We will cover all these technologies in detail in the coming up slides. Be patient a little, and this is just a coverage of giving you a brief gist of the tools and techniques. So another technique is deep learning. So a data scientist is also required to have the knowledge of neural networks, NLP, to draw meaningful insights from unstructured data and also to process such data. Now let's move on to discussing about the role of a data scientist. So what exactly does a data scientist do? And this will be clear once we go through a few job responsibilities of a data scientist. Now this data has been taken from Glassdoor. So let us look at the role that a data scientist needs to perform. And as you can see in the right hand side, the gist of the role is being listed. So a data scientist is required to build and test and iterate on the machine learning model. So we've already covered the machine learning is the indispensable tool of a data scientist. So iteration requires a lot of repetitive experiments with the data, and it is quite a complex process. And repetition is done to improve the results of the model. So a data scientist is really required to iterate again and again over the machine learning models. Although the building part is not so much, because already the companies are working under predefined, pre-designed, coded software. So testing and iteration becomes the indispensable part of a data scientist. Now, another role if we look at here is that they're working in teams. So working in team with the engineering team to deploy, validate, and monitor the machine learning models. So this is very important because once a model goes to the production state, so you have to monitor it. And also you have to undertake the deployment of it, how to really connect it with the front end and see how is it really working, what accuracy is it giving. And then most importantly, a data scientist is required to research data, identify opportunities. Now this means that drawing useful insights from the data by using various techniques, as we have seen earlier. So a data scientist applies all these techniques together to draw meaningful insights from the data. And now let us understand what all to learn to become a data scientist so that this role is suited for a data scientist and one can perform this very well. So the technologies to learn for a data scientist are programming language. It could be either Python or R, machine learning, deep learning, and NLP concepts, which need to be really very clear and solid foundation of the same. Another technology to learn is statistics, that is both descriptive and inferential. Another technology is database, knowledge of SQL and NoSQL, and big data. Big data, the knowledge of Hadoop, Spark, any one of them is required. So now let's cover these technologies in detail. Now moving on forward to the programming language. Now why a programming language is really required by a data scientist is to analyze huge volumes of data and also to perform analysis of the data. So programming language really aids in better analysis, manipulation of the data. So programming language generally used are Python, R, Scala, or Java, but generally preferred is Python, and it's the most popular language which is now being used in the data science community. R is also there, but on the production side, it becomes a little tough. Okay, so now we will cover both the languages and the important libraries to study for these languages. So now moving on forward to programming language, Python. So in Python, what all needs to be covered? First library is pandas. Now this library is very important because this is used for data analysis and manipulation. And pandas also provide very fast, flexible data structures. This means that numerous functions and methods are available in pandas, which allows you to perform data analysis and manipulation of the data very quickly and very fast. And time series analysis is also possible with the help of pandas. So the examples, like when you're forecasting weather predictions or stock prices predictions or houses predictions, then pandas really help, in data analysis and manipulation. So that's an example of that. Now coming to NumPy. This is another library which is numerical Python, and this is used for scientific computations. Now numerical calculation in machine learning is done with the help of NumPy, and this is the foundation, I would say the building block of Python. And all the calculations, mathematical calculations, scientific computations is possible because of NumPy. And NumPy contains multidimensional array and matrix data structure. With these powerful data structures, one can really perform efficient calculations in Python. All right. Now, moving on forward, we have the visualization libraries like Seaborn and Matplotlib. These two libraries are used for visualizing the plots, looking at the spread of the data and seeing how does the data look, whether are there any outliers, or what is the spread of the data. Is it normally distributed or it is unevenly distributed? So these visualization libraries really help us to visualize the data. And also another thing is that Seaborn is built over Matplotlib. That means that it derives functionality methods from Matplotlib, but offers more flexibility in terms of plotting the graphs, and better representation in terms of color, and aesthetically beautiful plots can be plotted with the help of Seaborn. So now we are moving forward to another language, which is R. So R is also preferred in the data science community, and data scientists work with R. R has very strong statistical packages as it was developed by statisticians, and R is really good for data analysis. But when you take next step into machine learning, R has its limitations too, as we have discussed earlier also. So now for R, if we are using R, then we can use dplyr package. Now this is used for data analysis and manipulation and for the exploration of data. dplyr is a very strong package, and it is a grammar of manipulation in R. This means that dplyr provides us a consistent set of functions. Then these functions are called verbs. So R has a defined language, and that language has to be preserved. So we use verbs here. So functions are called verbs here, and they help to perform the manipulation on the data. So now moving on forward, we have another package, and that is janitor. And this is used for data cleaning, like removing empty values or removing duplicates from your data and so on. So one thing to note here is that data scientists really spend most of the time in data cleaning, in transforming the data, in just removing the missing values or empty values, or cleaning. Cleaning is the most part that data scientists spend to. So these libraries can be really helpful when one is building models or one is working on various complex kind of a data. So now moving on further to another library, that is Lubridate. And this Lubridate is for date and time manipulation in R. And for Python, we have pandas. All right, for date and time analysis. And this really helps because it already has functions and methods predefined, which understands date and time analysis, and manipulation can be done very easily with the help of Lubridate. Now, another library that we would cover is ggplot2 for data visualization in R. Now, this GG stands for Grammar of Graphics. Now, in R, ggplot2 is used to make the graphs plots, and we work with layers in ggplot2. So with the help of these layers, we can plot a very complex plot with the help of ggplot2. And we can say that ggplot2 has very aesthetically appealing plots, and it gives us the flexibility to show our data in various structures and various formats. and we can always see what the data is saying. So we visualize the data with the help of ggplot2 in R. Now, I want to tell you something really very interesting as why is data visualization important? And now let us just uncover this thing. The significance of data visualization can be understood with the help of the image here on the left hand side. And this is known as Anscombe quadrant. Now, Anscombe was an English mathematician and he developed this quadrant to demonstrate the importance of data visualization. Now, this comprises of as we can see, four data sets. And these data sets have the same or identical simple descriptive statistics, right? But when they were being plotted, we get different graphs of each data set. Now, this is the importance of visualization, that the numbers and figures will appear same, but when they are plotted, they would be different. So to get the real picture and the meaning of your data needs to be plotted to get the true picture. All right. So it's always been said that numbers will not reveal the true picture, but the visualization of that data would definitely reveal it. So this was a very important Anscombe quadrant to visualize that, yes, data visualization, why is it really important? So moving on further, linked with this is data visualization tools that a data scientist uses, and one can learn these tools. It could be very handy. So a few visualization tools or softwares are Power BI, Tableau. Now, these tools really help you to visualize large data sets. And these powerful softwares, they can connect with multiple data sources in no time. You can build dashboards, interactive dashboards, powerful visualization, and even you can go on creating applications with these tools. So business intelligence tools knowledge is one of the requirements, but it is not that necessary. It's easy to learn and it's fun too. Okay, now coming on to another concept after programming language, and that is machine learning. Now, machine learning, this is the ability to understand algorithms, both supervised and unsupervised machine learning algorithm. So now we will discuss about supervised and unsupervised machine learning algorithms. So supervised is something when we work with labeled data, that means the output is known, and unsupervised is when we don't know the output and the algorithm has to make a guess, okay, what is this and which category or which cluster will the data fall into. So primarily we deal with supervised machine learning, and there are two types of supervised machine learning, that is classification and regression. And in unsupervised machine learning, we will see dimensionality reduction, and then various algorithms like clustering. And in clustering, there are so many algorithms like hierarchical clustering or k-means and so on. So a data scientist has to know about the algorithms, different kinds of algorithms that can be applied to a data to give good results. That's why it's a little vast, but it is really very interesting. So various algorithms like SVM, naive Bayes, random forest, k-means, good command over the supervised and unsupervised machine learning is required by a data scientist. Hyperparameter tuning. Now, this is again important because hyperparameters are nothing but they control the behavior of an algorithm. So you can say that if hyperparameter tuning is being done or performed on any algorithm, that is done to improve the results. So for model optimization, this is required. So to improve the predictions by tweaking a few parameters via hyperparameter tuning, that is what a data scientist also does. So to learn machine learning, moving on forward now, to learn machine learning in Python, what libraries are required is that scikit-learn is a package for machine learning library in Python. So the scikit-learn is the machine learning library, and this supports both supervised and unsupervised learning. And it also provides various tools for model fitting, data pre-processing, model selection, model evaluation, and other utilities. So if you're making any model or you're importing any of the algorithms, scikit-learn package would be used. Okay, now moving on further to R. So in R, if one wants to build machine learning models, so MLR is the package or caret is the package. So here MLR has all the important and useful algorithms to perform machine learning tasks, and caret stands for classification and regression training. So with caret, one can process and streamline model building and evaluation process. Also, feature selection could be done, and other techniques can be applied with the help of these libraries. These are very strong and powerful libraries which have consolidated packages, and you just need to import it in your project and use it. But the knowledge of how to use it, where to use it, is what the data scientist knows. So now moving on further to another technique and technology, that is deep learning techniques. So now when we want to work with complex data sets, when the data set size is huge, then traditional machine learning algorithms, they are not preferred. And generally we move on to deep learning. So gradually from machine learning, one moves to deep learning. That is a gradual shift. So when we talk about deep learning, what comes to our mind is neural networks. So when you're working with various kind of layers and neural networks, then deep learning is preferred. And neural networks they are a set of algorithms which are modeled, loosely after the human brain to recognize patterns. So just as to make the system more intelligent by just understanding the patterns and predicting. So deep learning is more advanced than machine learning, I can say. So a few deep learning algorithms are convolution neural networks, RNN, that is recurrent neural networks, or LSTMs, which is long short-term memory network. And there are many other deep learning techniques or algorithms. So these algorithms, they help to solve complex problems like image classification or text to speech or language translation. So these are really very powerful algorithms which are deployed to solve real world challenges and how to really make life simple. So now moving on forward to natural language processing. And what if I say that we all have sometime or the other had experienced with NLP and we know the end result? How? Remember Siri and Alexa? Yes, I'm talking about natural language processing. And this is a subfield of artificial intelligence. And this is concerned with interaction between machines and humans. So it is used for speech recognition, reading text, voicemail, virtual assistants like Alexa or Siri. And these are also the examples of NLP. So for Python, the deep learning libraries are MXNetR, DeepNet, DeepR, H2O. So talking about MXNetR, it is used for feed-forward neural network, convolution neural network, whereas H2O can also be used for the same, but H2O is for deep autoencoders. So when we move on to deep learning, there are more sophisticated terms and technologies that needs to be learned, and to improve the model performance, one needs to understand the working of algorithm, the limitation of these algorithms, and how one can really improve upon the model by iterating over these models. So now moving on forward from machine learning, deep learning, and another tools and technique, and that is statistics. So this is yet another important tool. Now, how does a data scientist use statistics? So it has been used to identify the right questions. So data scientists also use statistics to apply it to the data and ask the right questions. And once they know what the question is, they can use statistics to find answers. So statistics also help them to understand how reliable their results are and how likely is it that the findings can be changed. Now, moving on further, the statistics help data scientists to do predictive modeling. This means that using the past data to create models, and that can be used for predicting the future events. That is predictive modeling. Now, another importance of statistics is that it will help a data scientist to design and interpret experiments to make informed decisions. So now let us understand this with the help of an example. An observation was made that an advertisement X, suppose an advertisement X has a 7% higher click-through rate than an advertisement B. So a data scientist would determine whether or not this difference is significant enough to warrant any increased attention, focus, and investment. Now, this statistics would help us to experiment and design the frequency statistics or hypothesis testing and confidence intervals. So data scientists would work with these tools like frequency statistics and hypothesis testing to understand whether this is really important or not, whether advertisement X requires more attention or advertisement B requires more attention, focus, and investment or not. So statistics helps to determine these important and crucial decisions. All right, so now another use of statistics is to estimate intelligently. So data scientists estimate intelligently, that means by using Bayesian theorem. There are various theorems which help to estimate intelligently because a Bayesian theorem takes the result from the past experiences and observations and then make predictions. So this is estimating intelligently. And they can also summarize what estimates are and mean with the help of Bayesian theorem. So now statistics equip a data scientist to solve problems and make data-driven decisions. And now moving on forward to most common statistical methods, and this is descriptive statistics. So we talked about descriptive statistics. Now let us understand what is descriptive statistics. So descriptive means it is a summary statistics that quantitatively summarizes features. And some measures include, these are the central tendency measures which are being listed on the right hand side, like mean, median, and mode. And on the left hand side, it is skewness and variability, which are measures of standard deviations. And variance is nothing but knowledge of like how much is the spread of the data, right? Skewness is where the data is inclined, whether it is right towards the right or left. And determining the normal distribution of the data, we understand that are there any outliers in the data, how the data really is spread. So these descriptive statistics, they help us through the numbers that they give, we understand what the data is. Now moving on further to understanding what is inferential statistics. So a data scientist must also be able to use inferential statistics, because here inferential means we are taking a small sample from the entire data and we are making generalization about the entire data. So this is inferential statistics, inferencing something from a small data, assuming that this will also apply to a large data. Okay, so we make inferences from a sample about the population. Now, the methods for this includes hypothesis testing, probability. Now, probability is used to predict the likelihood of an event. Regression analysis is yet another method. So regression, what we do is we model the relationship between variables, right? ANOVA is yet another, which is analysis of variance. This is a test to compare the means of different groups and how different they are. And based on the results, we take decisions. Another method is chi-square, and this chi-square is used to determine any relationship between variables or compare the result between an expected and an observed values. So this is inferential statistics, and now we will move on to another technique, and that is from statistics to databases. So let's understand what are databases. So now data has to be stored before analyzing or making predictions, and to store the data we have databases. Thus the knowledge of database again becomes important for a data scientist. So every time a data scientist would have to retrieve a data, he has to look upon a person who could help him retrieve the data. So it is better that a data scientist should be equipped and should possess this knowledge, so that whenever the need arises to access the data or store the data scientist can do it by himself, right? So that is why database knowledge is required. So now coming to the types of databases, that is relational database first we'll be talking about. So as it is said, relational, that means the data has some relation between itself or between each other. So the data is related and it is stored in a tabular format in some predefined schema in the databases. So what happens is that when it is in a tabular format, when it is in a clean format, the retrieval becomes quite easy. It's smooth. It is not complicated. And this data is related somehow. So the example I can say of relational databases are MySQL, Microsoft SQL Server, or Oracle databases. And now another type of a database is non-relational database. Now, non-relational, that means it is not having any relation. And this database it does not follow any preset schema, and also it is not in a tabular format. This is not important. And we can store any kind of a complex data, whatever complex data we have, unstructured data we have, that goes into non-relational database. And few examples of non-relational database are, as we can see here, MongoDB, Apache, Giraffe. Now, let me tell you something about Apache Giraffe. It is optimized for storing relationship between nodes. So why is it important? Because this shows connection between entities in social graph. And this software really makes social network data more informative, and it provides real-time graph processing. So when you are analyzing huge volume of data from social network sites, these non-relational database really help you to understand, analyze, store the data, and find some relation between them. So that is why it is really important to have the knowledge of these databases, NoSQL databases. And MongoDB is optimized to store the documents, right? So there are various non-relational databases. I've just listed a few here. Now let's move on from database to another technology, and that is big data. Now, to understand or the ability to analyze the unstructured data, this is relevant in the context of big data. So, big data, we are moving forward. And big data, what happens here is that we are dealing with large and more complex data set day by day, and companies are dealing with huge volumes of data, especially from new data sources. So, these data sets, they're so voluminous that traditional data processing softwares cannot manage them. That's why the big data technology is really helpful. And big data, it is a collection of data from diverse data sources, and it has certain characteristics like volume, variety, velocity, and veracity. So these are certain characteristics of big data. Now, moving on forward to big data technologies. Now, why they are needed? Because to manage big data, we have to use big data technologies, and they are classified into data mining, data analysis, data visualization, and data storage. So these are the big data technologies. So all these big data technologies are not required by a data scientist. We will particularly deal with data storage, which is required and which is really important to know by a data scientist. So for data storage, we have Hadoop. So we will cover first Hadoop. What is this Hadoop? So Hadoop framework is there to store and process the data in a distributed environment. So which means that it can store and analyze the data which is present in different machines, and it also comes with very high speed and very low cost. So the companies like Microsoft or Intel, IBM, they use Hadoop to store and process data. So when you're working with huge volumes of data, you need to even store and analyze it also at very quick speed and at low cost. So Hadoop gives you that flexibility and power and those features which you really need. So now coming on forward to another big data storage is MongoDB. Now this is again a NoSQL database, and it offers what a direct alternative to rigid schema which is used in relational databases. But MongoDB, another flexibility is that while handling a wide variety of data types at large volumes, you can use MongoDB, and it also can be used for distributed architectures. So again, MongoDB can be used, and companies like MySQL, SQL Server, they use MongoDB to handle data. Another big data storage is Apache Spark. Now, Apache Spark is again used for large scale data processing. Now, both, I would say that the Apache Spark and Apache Hadoop, they are both open source frameworks for big data processing. There are some key differences, like Hadoop uses MapReduce to process data, while Spark uses resilient distributed data sets, RDDs. So now moving on further for other technologies which are recommended for a data scientist is Excel. Now, Excel is used since decades for analysis, but now more advanced languages and more simple languages are there out, like Python and R. But Excel is here to stay. So using Excel for basic analysis like formulas, pivot tables, VLOOKUPs, or VBAs, this can be used by data scientists. So VBA is nothing but Visual Basic for application, and this can help automate repetitive word and data processing functions, and it could also help you to generate custom graphs, forms, and reports. So Excel is really a very powerful tool which is yet even today which is being used. So now we are moving on forward to web scraping. So scraping libraries like Beautiful Soup in Python, it is also known as BS4, or Scrapy, these are popular libraries in Python, but if one is using R, then RWest package is useful in extracting information from the web. So web scraping is not there in most of the job responsibilities of a data scientist, but if one is equipped with this and have a knowledge of how to use various APIs and get the data from that various resources over internet, then this could be a real help. Now, moving on forward to Linux. Now, why is Linux required? Because the company operate on various operating systems, not necessarily Windows. So Linux is the most recommended language, I would say, or the commands need to be learned for Linux for a data scientist, because anyways, when you're joining a company, you have to learn those commands. So basic knowledge, not much, just basic concepts to how to operate Linux, the commands. And this would be really helpful, as Linux is considered more secure as compared to other OS, and companies really want that their data should be secured, their information should be secured. So a different operating system is used. So that is the entire idea about learning Linux. But this is not essential, but this is an option. Now, moving on forward to another technology, that is Git. Now, Git is for code management or your source code management when you're working in teams, when you're sharing the code. So various versions or various changes could be made in that code by various people. So Git provides one source wherein all the changes could be merged into just one source, and one gets an edited version. So this is very, very handy, and it saves a lot of time. And making collaboration is very easy here. You can also allow multiple changes to be merged into a single source, and it is basically a version control system. Very useful Git. So Git commands and Git knowledge, not commands, but at least you know how to really work with Git for code management. Now, moving on further to another, this is again an option, that is cloud technology. But few companies really now are looking for data scientists who also know the knowledge of cloud technology. And now, cloud technology like Azure or AWS, so that you can gain access over to the storage of software or servers over the internet. So, how do you really access that? How do you retrieve information from cloud? By using AWS or Azure or different technologies that the company is using. So the benefit of why company are resorting to cloud is that it provides unlimited storage space and very high speed. The backup rate is good, and it restores the data. It is also cost effective, and it saves much of the infrastructure cost of the companies too. So that's why companies are really moving forward to cloud, and they need people who can really access cloud along with deploying machine learning models. So this is preferred. Sometimes it becomes important too. Okay, now so moving on further to how to structure the learning process. Now, the above list of subjects could be really overwhelming and can really, demotivate a serious learner in the long run. So, how one should structure the learning process to scale up the ladder of a data scientist. Now, all these topics need not be learned at one go, but parallel learning is recommended here. By parallel learning, I mean that learning Python first and then moving on to data analysis visualization with the help of various projects, building machine learning models with the help of one programming language. That will give the idea of how really algorithms work on data, understanding the answers or the outputs from the data, and then tweaking in with certain hyperparameters and improving those results. Once you are done with machine learning, move on to deep learning and apply those statistical analysis, the inferential statistics and descriptive statistics, because we find the description, the statistical bar from the data, and understand how does it work by various plots also. So statistics really is helpful in understanding the results. So these learnings are being used in unison, not individually. So the knowledge of all these things are really required. So now when once a programming language is done, you're done with a few models of machine learning. So you know now how the machine learning algorithms really work and what is hyperparameter tuning. You move on to databases. So database knowledge on how to work with relational and non-relational databases could be taken up. Connecting with the server and retrieving various data and information. That could be a real help, because in companies, when you're working, you have to connect to a different source where the data is lying in different machines. So database servers help you to connect data and retrieve the data from those machines. So following certain commands and knowing how to retrieve and fetch the data from different machines could be a real help. And big data technologies, of course, moving on forward, then to big data technologies like Hadoop or MongoDB, understanding how do they work and how you can add this thing to your data science and consolidate all the learnings that you have got. So once you are done with a few basic concepts, move on to a higher concept. Do not take a higher concept before, because it will demotivate a learner. So now, how to approach the topics. So a general advice is that do not spend more than 3 weeks with any subject. Keep on switching in between the subjects in order to retain the interest and to be on track. And parallel learning is recommended rather than sticking on to one subject like programming for months together. This will really demotivate one and you would not be on track. So after learning a few basic things of programming language, move on to building models. This will keep you interested and motivated. So parallel learning is highly recommended, and data science is a multidisciplinary field. And so a data scientist has to manage multiple subjects together, apply the learnings, and in the end, all the combined learnings will lead to a single goal, and that is data scientist. Well, this is it from my side, and I hope that this structuring and learning of the process and the data scientist roadmap is clear to all. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!